So you have the laser point. Would you mind wear this?
Yeah, sure.
Because I think the recording also has all.
Okay, cool. So first, my name is Zachary Wood, and I'm a master's student with the program of computer vision. So just a brief disclaimer, I'm the first one presenting, so my project is still in the works. So this is more of a kind of progress report, which I think is actually what I named the file. So I'm doing a guided medical image synthesis using a control net for data augmentation, which is a fancy way to basically say I am trying to generate synthetic medical images. So actually, before I get in, I'll just kind of describe my background for this. I did an undergraduate at the University of North Carolina, Wilmington. There I did information technology with a focus on cybersecurity. And then since then, I've been working part-time as an AI engineer for a small cybersecurity company that's based out of North Carolina. And then relevant kind of research is I just had.
Sorry, I just want to make sure your mic is green.
Is it? Okay, cool. Oh, good. Yeah, and then I guess relevant kind of like research is I just had my second research paper published for enterprise-specific chatbots, actually like 2 weeks ago, so that's kind of fun. Now, with that said, back to the progress report. So kind of medical data set challenges. Here, there's limited availability of annotated medical data sets, and then kind of the more kind of targeted focus that I was taking to attempt to really solve through this project was a kind of class imbalance in pathology data. And so you have rare conditions that are underrepresented, and then in this screenshot, which the main reason I have this break his data set instead of the MedMinst data set, which is the one I ended up using, was because I found this pretty little chart that was already created for me. So, but point being is that this chart is a visualization of a imbalance, basically, where you have basically half benign and then 2 out of 3 malignant. Okay, I can't speak. Bad things. Now, the other aspect is there's a high cost and time investment for medical data collection. And then some other aspects that I didn't highlight here are also the privacy concerns with data, because people may not like having their information taken, and it's more specifically used for generative purposes. So kind of continuing on that, the motivation and research gap, current generative methods struggle with maintaining anatomical accuracy in medical images. This somewhat stems from you have a lot of these, Stable Diffusion, for example. It's primarily scraped off of images throughout the internet, so art, pictures, and most of that doesn't pertain to medical-specific images, whether that's MRI data or the actual pathology, cell depictions. So continuing on. There's limited exploration of conditional diffusion models for medical data augmentation, and that somewhat I attribute to it being a relatively niche area. It's most of the applications that you see that people are writing research papers on and publishing and then developing solutions for all are in the span of art generation, or you have a lot of very specific business use cases that kind of a lot of focus and money has gone into because people want to spend money on what makes money. So for my specific project and what I'm trying to do here is essentially generate medical images using a control net to structure and guide. And then just the personal way that I work and develop, I typically will do a little demo and then continue to develop off of that. So I have a version 1 and a version 2. Version 1 is basically just a proof of concept where I was just testing and experimenting with a control net and using canny edge detection to basically extract specific details and then using that and a prompt to generate an image with Stable Diffusion. And the other consideration that I was trying to do was I tried to play around with the challenge of seeing what I could run on my local machine. I don't have the machine specifics in here, but My local machine is essentially like a high-end consumer gaming computer. So I have a, let's see, a NVIDIA GTX 4090, which has 24 gigabytes of VRAM, which lets me run a lot of stuff locally, but then there is that hardware constraint. So just kind of high level, I have a little slide here on the diffusion models and ControlNet. Essentially, as we've talked about in class, the diffusion models, you have a lot of static, slowly diffusing that to get you the desired image. The idea behind ControlNet is to provide a specific template. You can think of it as like a drawing that then the diffusion model uses to populate, and basically keep the same thing or with some form of consistency. And then you combine that extracted control area with a prompt for more consistent accuracy with what you're intending to generate. And then here is a little image of canning conditioning. I just took this from the actual research paper that published it because I felt like it was a pretty good visualization for it. On the, let's see, yep. On my right, you guys' left, you can see an image that's like a fantasy house with a waterfall on one side and the house on the left. And then you can see the canny conditioning on the right side, which is essentially just the outline of everything. So like I kind of alluded to before, think of it as like a coloring book with it. It now has a rough guidance of, okay, I want to generate a house on the left. I want to generate mountains on the right. And it would theoretically be able to accurately generate something that is, you can basically see a chain of events to get to it in subsequent generations. Now, the specific data set that I've been using is the PathMinst, which is part of the MedMinst V2 collection. And I chose this one specifically. Actually, in my project proposal, I had a few different data sets that I was looking at, but I went with this one because it was lightweight, easy to download, and then I was able to put it on my local machine. And then as it's just me working on it, there's only so many hours and experiments that I can play around with before I run out of bandwidth. But then the specific variation of this is the 128, so that's 128 by 128 resized images. So version 1 architecture is basically just a ControlNet implementation, and once again, this was just to see what I could generate off of a Stable Diffusion v1.5 with ControlNet applied. And so here you can see a visualization of that. So then version 1 sample results in the, let's see, the uppermost image, you can see the sample image that I took from the PathMinst data set. And then you can see the canny edge detection that I did there and the generated image. And this is just the initial version. And so you can kind of see, one, the staining patterns are not there. And this is also like another area that I think I actually have mentioned later in my PowerPoint, but certain medical domain specific things such as staining patterns, that was something that I personally wasn't aware of. And so that just in my own limitations there highlights a disconnect between domain specific knowledge and then how you might go about implementing a solution for this. So then with version 2, which is where I was trying to play around with something like a little bit more to generate more accurate images, building off of the ControlNet. Here at the bottom of the image, you can see what I tried to do for stain normalization. One of the concepts that I encountered when I was trying to solve this problem, basically, was the concept of normalization for color schemes, especially when it comes to image generation. And so one of the things that I actually also encountered as I was doing this, or actually creating the PowerPoint for this, was I realized that I have an error in my code where I actually am putting the order of operations in the wrong place, which, okay, well, jumping ahead, but high level here, I'm trying to do stain normalization, I'm trying to do enhanced edge detection, and then I'm also playing around with LoRa, which is high level, a very lightweight way of fine tuning. And this is all off of randomly extracted sample images. I have, I believe, 8 in my code base that I just extracted out of the PathMinst subset of the MedMinst dataset. So version 2 implementation, these images actually here are generated from a version of the LoRa adapter integration that I played around with. Once again, this is a work in progress, so I apologize for some things being slightly out of order. That will be refined in my final report. Okay, and then high level for data preparation. Essentially what I'm doing is I've been testing off of mostly the same image, which you can see here. I've used the top uppermost image. That's the sample that I've been running majority of my tests all around, trying to generate some level of consistency and more importantly, some level of consistency that features the same, shading, features the same color scheme, and would look ideally believable. So current results, like I said, right now it's still in progress, still running tests, and I will probably end up doing a version 3 to try to combine everything that I find and get a more polished, smoother workflow than I currently have. And then, so some of the things I've also played around with and actually intend to go a little bit more into the future is, and more specifically, more in the version 3 and version 2 finalizations, are playing around with different medical specific prompts. This here is just an example of one where I can play around with. Obviously, this is a very lightweight prompt too. This is very little content to it. There's very few keywords here, but it is enough to generate consistently. So as I started jumping ahead earlier, technical challenges that I encountered: high frequency noise in the medical images affecting the edge detection. As you can see here, it looks like a giant scramble of things. And what I was actually realizing when I was creating this and kind of looking at my results and doing an analysis of what I currently have is that this is likely due to me putting stain normalization in the workflow prior to the canny edge detection being applied to it, which likely is, at least in theory, causing this. So some of that is what I intend to continue trying to sort out and identify what the cause of everything is. And then jumping back to another point that I brought up earlier was the domain adaptation requiring specialized knowledge. This being that I have no prior exposure to the medical world prior to this course. So a lot of the things such as like stain normalization, even really analyzing medical scanned images, it's all new, and so I'm trying to learn and figure out. I'm sure there's a lot more stuff that I'm still missing just because it's like such a broad domain. So next steps that I intend to complete over the coming weeks are the complete LoRa fine-tuning implementation, and that includes a more robust version of it than I currently have played around with. Implement a quantitative evaluation pipeline. I have some code already in play to evaluate it, but as I'm still working on it and developing what I intend to be the final result of the generation process, that's still a work in progress. And then kind of downstream task evaluation. I intend to, well, ideally, part of the information I included in the project proposal was essentially playing around with the idea of like how these medical images could be theoretically used to train and augment real data that was collected, so to augment the existing data sets that are out there. However, I need to get the generation down first for that to effectively, work in that use case. Otherwise, it's kind of a null point. So just rough timeline here. And then made a quick little slide on conclusion, final directions. So, summary, a successful implemented conditional medical image generation with domain-specific enhancements. And once again, all of this I'm running on my local machine, so I am somewhat bound by hardware limitations if I, try to do any serious level of like fine-tuning or more specific training. And then just highlighted applications. So any questions? That's a good question. That was something that I did play around with. However, I was also mostly focusing on what I could do without any specific models that were already trained on the medical data. So all of the implementation that I'd done was basically no training on it. Playing around with LoRa was the closest that I've gotten to actually using like fine tuning. That was all just trained myself.
So, but the question is, did you find any existing model already that has been trained on medical data, like medical control net, right? So, like, have you found any?
I have not specifically like looked into.
Yeah, I think it would be nice to, any of the project. So I think you find a very good, issue, right, by yourself, right? So like, without just take it off the shelf control net, right? You figure out, okay, there's a huge gap between the natural images, right? Control net has been trained on any medical domain knowledge, but in your project, you figure out because of this, there's a gap in terms of understanding the medical data, right? So the generation quality maybe suffer. I think to this point, maybe it's a kind of, motivates you to kind of see if there's already some work, like they are adapting or they are fine-tuning or any of the stable diffusion or diffusion model that has been trained on medical data, then that could be a better version as you are using the control net.
Right? Yeah, I mean, I actually like that idea. I think it would be really cool.
I think it would be cool to not necessarily constrain yourself based on the control net baseline, but you can always go around, like have a specific or domain-specific generation pipeline or model, right? That is specifically trained on the medical data, and maybe using that as your pre-trained model and do the further fine-tuning. That may be even more effective. So I think that's what Jeffrey is trying to.
Thank you for pointing that out, because 100% I had been kind of mentally limiting myself just off of that little boundary there. But I think that would be a really cool way to kind of compare, what I was able to see from this, non-fine-tuned, and then essentially highlight the gap with a more specific model.
Yeah. Okay.
But awesome. Thank you.
Yeah. Any other questions?
Yeah. I might have missed it because I came late. So in the LoRa fine-tuning scenario, are you using control net or not using control net? I just had a question about the setting.
I am using control net, yes. Okay. I should highlight it.
I had done some experiments with LoRa-based fine-tuning in a different domain. You might want to try without control net because you are using edge maps, right? So the patterns that the model will generate will roughly be congruent to the edge map you provide as input. So whatever pattern is there in the edge map should be there in the generation ideally. Right?
Okay.
So just using LoRa fine-tuning might lead to like more diverse patterns.
Okay, gotcha. Yeah, I know in my code right now I had it off of like specific seeds, so a consistent generation based with that. But gotcha, thank you.
Any other questions, feedback?
You were using canny edges, but have you thinking in exploring other kind of conditions, like it's not just canny edges, maybe like masking?
I hadn't played around with any in the current implementation, but it's certainly something that I'm trying to explore with adding additional features and just kind of like observing, how it will affect the generation, how it compares to the previous ones. I think right now I probably have close to like 100 different generations all like sorted that I'm visually just comparing the results, and then also tracking the logs for each one so I can do a direct comparison. Because obviously, if I generate something like 2 months ago at this point, it's hard to remember the specifics behind it.
Yeah, that's a good question. I also have this one. Maybe you can go back to the slide where you, since you are the only one presenter, so we want to give you more feedback because also I think this is a really interesting project. Also, some of my suggestions later will also help you to prepare a better presentation because I do want to give you some suggestions how you can further improve the organization, the structure of the presentation to have very clear. So yeah, I think I have the same question is, why do you use edge as the condition for the generation? Because a lot of, I think Jeffrey also mentioned, right? So we can also using segmentation mask. If the data set itself has, let's say the task was like the pathology data was originally designed for segmentation task. They have the images and the paired segmentation mask, right? So what you can do is take that segmentation mask, which is already ground truth, then you can using that maybe to generate new data, right?
Okay.
Maybe if it's the segmentation mask. So here I'm assuming because you're taking the pass and missed, right, which is for the classification.
Right.
They only have like label information. You don't have any other pixel-wise labels, right? So that's why you want to using like easy to generate pseudo label, right, which is the edge. Is that the motivation?
It's somewhat. I mean, more of this is really my first major. This course actually itself is my first exposure to computer vision and any kind of ground and kind of moving forward framing. And so this was just the idea that I came to with, and then given that it's just me, I kind of just picked an idea and then started to see where it took me and see what I can learn in the process.
Yeah, but I think a more logical way, before you jump into any kind of decision making or starting to prototype anything, it's always took extra step to think about and also look at the data, right? So like. I think the first example you showed is the brick test, right? The pathology data, you have a huge imbalance between different classes. It may be good to show what this kind of histopathology data look like between these two classes. So, is it because a lot of this kind of structural difference? Maybe leading to these two type of classes, right? So like benign or malignant, the tissue, the structure may be very different. Then, I'm able to using some edge detection, right, to generate these kind of structure information, right? And then using that to guide the generation. But if structure, let's say benign and malignant, they are pretty much the same, then do you think like using the edge, which is more like a global structure information to guide the generation, is going to be a proper way to a proper condition, right? So like what if the difference or distinction is more on like the color component? I'm just making things up, right? So
no, that's good points. Good
not
data.
The structure,
absolutely.
Right? So I think that's the fundamental question, right? So I think that's the people will mostly think about, why you are specifically using, edges, as your condition for the generation, and will that increase, or serving the purpose or making the data useful, right? Otherwise, you're generating a bunch of maybe not so useful data.
Right.
You can make the class distribution more balanced, but not necessarily the generated data is going to be serving your purpose, right? As you first mentioned, in the medical data, they have some anatomical structures or some other purposes. It's not like some natural images, right? For specific applications, there are specific cues the model has to focus on, right? So that the decision making can be more accurate. So I think that's something we really need to think about, and hopefully you are heading to the right direction. So maybe in the final report, I think the motivation could be something really put into the thoughts, right? So is the edge generation is really helpful for you? And also, in the presentation, will be nice to show a couple of examples, right? So like this is the pathology images, and you have different classes, and with more visual examples, maybe the audience can also help you, give you some more informative, suggestions. If besides maybe edges, maybe other things we can apply. Let's say if segmentation is more accurate or more appropriate,
Gotcha.
Maybe you can apply a SAM v2 model, right, to easily get the segmentation, because the segmentation may ignore some of the small nuances, because edge map maybe give you very noisy, right? So small patterns may not be necessary good, but the segmentation, right? So here you have a lot of noise, right? So in this case, so and you may, this could be improved by maybe adjusting some of the threshold from edge detector, right? So you can play with the threshold maybe to generate a better or cleaner edge detection map, then could improve the conditioning to help the generation. But it also, keeps you wondering, okay, maybe another, condition like segmentation mask could be a better one, right? Because here you don't have to necessarily do the manual annotation. You can using the SAM model. A lot of these segmentation or medical segmentation model has been already trained on these pathology data or medical data. So they are supposedly to do well, a very good job on the segmentation. Then you can deploy that to generate the segmentation mask and using that. So I think this will come to a lot of initial thinking, right, about why you are using this, right, and will this, leading to a useful data generation and serving the downstream task, right? As you mentioned, ideally you want to do some downstream task using the generation model is going to be help the classification. So I think that's, the first time you mentioned the detection, I immediately have this, question. I was hoping you have some example, or in the later slides, you will have this kind of explanation, right? Why you are using the edge. But I think this is something missing. So I think, I think this is really helpful for us to really understand why you are coming, from this. Other, suggestion I would give you is maybe have more detailed layout about the methodology presentation. Okay. So, you have the control net, and you show a slide with the pose image as the condition, but it will be nice you incorporate, or maybe you draw another frame by yourself that is plugging these pathology data, right? So this give you the audience the overall picture, right? So you take the original pathology images, you apply the edge detector, you generate the edge map, right? And then you feeding this edge map to the stable diffusion or control net, right? So then generate a new data. So I think that figure will connect directly to your project itself. I mean, for us, we understand the control net because we mentioned that in the class, but what if we don't mention that, right?
Okay, I will say that some of the design that I was going for the PowerPoint was I wasn't sure how specific, given that, what was covered in the course, so I kind of kept it higher.
Yeah, so I mean, you're doing a good job, but I just want to, you're brave enough to do the first presentation. So I really appreciate that. So, but I just want to, just a very general, maybe suggestion for the other presenters, right? So how we can further improve so that the organization or logic flow is very clear and simple for us to understand, because after all, we only have 10 minutes. Everyone needs to quickly grasp, right? So what is this project about? Why you are proposing this? Basically your thinking process, right?
So, and the other thing too that I will kind of double down on some of the things that you just said here is this has been the primary image that I've been testing off of to test generations, to test different processes, which obviously, as you can see, it's very easy to kind of use something like, Canny Edge to actually highlight it because it's, well, there's differences in it. Right. And so for a case, as you mentioned before, where if there were, images that, it's very hard to maybe make out some of these details, it would be a less than a perfect solution.
Yeah. Okay. So I think in terms of the technical part, so I think definitely do not limit yourself to control net. So let's see if you can find some maybe diffusion model has already been trained on the medical data. And if you can find some pathology model already. So remember in the very beginning when I think I presented this project idea, right? That is IHC image, and also I forgot the other modality, so which is more expensive, like doing the conversion. So it's the competition I think they host. They have the data set. So I'm assuming there's already people have been trained this kind of generation model. Or even you can try, I mentioned a couple like CT to MRI, models has been trained. I mean, they also have difference, but at least they maybe have some medical knowledge there. So definitely trying to see if you can find any existing model that has been tuned in the medical domain. Maybe you can leverage that rather than using the control net, or you have to fine tune it yourself. Of course, you can further tune that model for your pathology data generation. A second is, I'm still thinking about, for this kind of images, right? So you take let's say, you are able to generate a very accurate, edge map, and you are able to resolve this kind of color issue, right? So right now, the generated images are not, very realistic as like a pathology image, right? So let's say you also solve that issue. Then what do you expect, right? Like how do you evaluate? I mean, we can using these usual like FID or SSIM metric, but in terms of these, anatomical, functions, right? So what is expectation? Right? What do you see will be a very good generated image? Because you're doing the classification, right? So do you want to understand or maybe see some of the patterns that is related to maybe one particular class, and also you see some patterns generated that belong to another pattern that maybe belong to class 2, right? So that's also very important, right? We are not interested in generate some very good looking images, but the anatomical function, right, has to be there. Otherwise, you are just generating a bunch of images for show or for display, rather using that for a specific medical problem, right? So I don't know if you have put that thoughts into this.
Honestly, it's been very, kind of high level. I just was focusing primarily on just trying to, do the kind of base generations so far. But no, this is good feedback that I definitely need to dive into a little bit more. And then exactly, for that, just continuing, or more specifically, looking into actually implementing some of the more fine-tuned models.
Okay. Yeah. So I think this is a really interesting, project, and generating images is for on the first glance, right? I think a lot of people may be a little bit suspicious about how useful is the images, right? Because not just natural images, right? There's a lot of effort, a lot of this kind of semantic concept can be easily synthesized. But for medical images, right, maybe a lot of patterns are really, very small changes, very nuanced differences. So how the model is able to tell these kind of small nuances and generating that is quite challenging, right? Not like just generating houses or mountains, right? Which is very easy, but generate something maybe at the tissue or cell level, right? Has a very distinctive characteristics. It's really challenging, and the model has to understand that in the first place, right? Otherwise, how do you expect the model is able to generate, right? So the reason these models are able to generate very good house or maybe mountain images because they understand the semantic representation of these different classes very well, right? So they are able to generate. So I think the representation knowledge of this medical domain is really important for generating something that is useful. So, but I encourage you to think more on this. And I don't know what's your future plan it is. If you are considering this could be something really interesting and you want to plan for a long term or maybe further improve that, these are the good questions you have to think about, right? Okay. Especially, I don't think you have like FID or SSIM metric will be enough if you want to publish a paper or anything. You need to have downstream evaluation to make a point, right? So the generated data is able to mitigate some imbalance issue and help the classification performance. You need to show that the generated data is useful, is able to help the downstream tasks like segmentation, classification, etc. Yeah, so that's my if you want to have a biggest takeaway, I think that's probably it. Well, from me. Yeah.
Okay, cool.
Yeah.
Thank you.
Okay. Any other questions, suggestions? Okay. Any other suggestions, questions from online? Okay, great. So yeah, I think this is it. Thank you so much for the presentation. So yeah, hopefully, this will be a good example. So for the following up presentations, prepare a very clear or well organized presentation. So in this case, right, so everyone can easily understand and maybe give you more feedback to help you improve. Okay. Okay. All right. So I think we don't have any further presentations today. Let me double check. Okay. So we have only one. So then next class we have 4 presentations. Okay. So from Riley, Jordan, the first team. The second team is Matthew. The third team is Terhip and Nicole. The fourth team is Ashmal and Parth. Right? Okay.
I actually did have another question. I think it would also pertain to everyone else as well. But so some of the reasons that I stayed in the, boundaries that I did was because that was specifically what I wrote on the project proposal.
Yeah.
Like, are you okay with us, deviating from that?
Yeah, totally fine. So like I mentioned many times, so the proposal, because you don't have any evidence yet, right? So you just think, oh, this maybe work, and this should be like a straightforward or maybe intuitively makes sense. But during the experiment, you figure out, oh, this is not the case, and this is something I need to pivot. Definitely go for it, right? So the proposal is just something for you to get started. But of course, everything you can change, as long as you have the the right justification for that. Yeah, that's totally fine. Okay. Yes.
I was told on the 7th, we only are allowed a maximum of 6 people per day. Is that 6 groups?
Yes.
On the 17th, I think I accidentally signed up. On the 17th, I think there might be 7.
Yeah, maybe. Yeah, I don't, because there's too many presentation on one day. Then there's limited time because you can shift to maybe 4:10. Is it possible for you to do that? Then maybe we have to go overtime in that case. So I think 4:10 is the best choice for you guys. Yeah.
We're not ready. We can make it fast, the presentation.
Yeah, if you can, make it fast and do it well, that maybe is okay. But I mean, I wouldn't give you a lot of feedback in that case. So, that's another advantage if you want to score very high in the final, report in the project, because I do value the contribution, right? So, what kind of hard work you have put in, because, I think we have very graceful, grading for your assignment, but I may have a very strict grading. I'm going to grade it myself for the project, okay? Because I think the TA may not give very fair, because I want to see how much effort have you put into this final project, okay? But I will try my best, give you the feedback, given the time constraint. So, but yeah, if you are not ready, then you can do it on the last day, okay? Okay, all right. Okay, all right, thank you, everyone. I'll see you on Thursday. All right.
Thank you.